Hopefully it came across in our discussion of the properties of matter that one of the most important properties for us to discuss are the changes that matter undergoes. Now, likewise with the properties of matter, we have two basic areas of change. Similar to the properties, changes can be categorized as either physical changes or chemical changes. It's important for us to realize that changes in matter are just a subset or a subcategory of properties. So changes are considered properties. So if we look at physical changes, these are changes to matter that do not result in a change in the fundamental components that make up that substance. So for instance, when you change states, boiling, changing from liquid to gas, melting, changing from solid to liquid, or condensing, changing from gas to liquid. These are all examples of changes that happen that don't change the fundamental components. So if you looked at water, all three of these changes, we would still have water present. Chemical changes, on the other hand, involve a change in the fundamental components of the substance. In a chemical change, you are going to produce a new substance. Now, how are you going to know if there's a new substance produced? Well, you're going to look at the properties of the substance that you produced. Are they different from the substance that you started with? Chemical changes are also called chemical reactions. In a chemical reaction, you start with reactants and you form products. Now, here's another situation where we need to learn to differentiate between physical changes and chemical changes. They aren't always easy to do, but if we kind of keep in mind that idea that if we have formed a new substance, that would be a chemical change. If we have not formed a new substance, that would be a physical change. If we keep that idea in mind, then it shouldn't be too bad. All right, here's something that might help us a little bit to understand this. So if we add heat to solid water, so here we take a look at our solid water here. If we add heat to that, it is going to change to a liquid, and we can obviously continue to add heat to it, and it will change to a gas. But in all three of those, we still have water. So we haven't changed the identity of the substance. So in that case, those changes would all be physical changes. On the other hand, if we take a sample of baking soda and we add heat to that, that baking soda is going to break apart into something called sodium carbonate and plus water plus carbon dioxide. So you can see that in this case, adding the heat doesn't change the solid baking soda to liquid baking soda. It's going to change it to a totally different substance: sodium carbonate, water, and carbon dioxide. Here are a couple that you can try out for yourself. So classifying each of these, and again, if you want to, after we get done reading through these, you can pause the tape, think about them a little bit. Again, keep in mind that you're looking at, did the fundamental identity of the substance change? So the first one is iron metal is melted. Iron combines with oxygen to form rust. And we're back with sugar again, fermenting to form ethyl alcohol. Iron is melted, and obviously this is going to be a physical change similar to melting water. You still have iron, it's just in a different state. Iron combines with oxygen to form rust, so here's a chemical change. So the iron and the oxygen actually react together to form a new substance with new properties. Nice shiny iron is a silvery color. Oxygen's a gas, and that substance you're forming, that brown kind of brittle substance. It doesn't have anywhere near the properties of what you started with. And then finally, this one we talked about before, the sugar ferments. It was a chemical property, so it shouldn't surprise us that it's also a chemical change. And then, by the way, any chemical change can be described, or it can be listed as a chemical property as well. Yeah, we should point out too that a chemical property could be a chemical property could be a property, or it could be a non-reaction to something. So if you looked at a chemical that doesn't react with something, that would be a chemical property as well. So again, we'll do more practice with these, but kind of work on, as you see things happen, as you make an egg in the morning, think about it. Is that a chemical change that's happening, or is it a physical change? When you add sugar to your tea in the morning, that sugar disappears in there. Is that a chemical change or a physical change?